Hello everyone and welcome back to the new video of this channel. So today we'll be solving a problem which is neighboring bitwise dot lead 42683 problem. So let's see the problem statement. So problem says that a zero indexed array derived with length of n is derived by computing the bitwise dot of adjacent values in a binary array original of length n. Okay, specifically for each index I in the range of 0 to n minus 1. We have two conditions. If it is the last index I equals to n minus 1, then derived of I is basically original of I or original of 0. Otherwise, derived of I equals to original of I or original of I plus 1. It is something like a cyclic kind of thing. Okay. So, given an array derived, your task is to determine whether there exists a valid binary array original that could have form derived. Return true if such an array exists, otherwise return false. Okay. A binary array in a array contains only 0 and 1. Okay. So let's see the constraints also. So constraints are basically 10 is to power 5 and can go up to 10 is to power 5. So we can't use big of n square technique because in that technique it will go up to 10 is to power 10. But our good solution or working solution can be less than or equal to 10 is to power 8. So big of n square can't be work. So can we use big of to the power n? If I use zeros and 1, if for every element I use if it is 0, if it is 1. So to power n technique, if it is work, no, this will not work because to power n is basically to power 10 is to power 5. That will also give me a TLE. So which technique will work? The technique that will work is big of n technique because big of n technique is basically big of 10 is to power 5, which will work definitely because it is less than 10 is to power 8. So basically, let's see the example. We have given a derived array which is a 110. Now we have to find out if there is any array that is possible by using the derived array. Can we make the array like original array? If it is possible, then we will return true. Otherwise, we will return false. So let's see the approach for this problem. So this is the derived array, and this is the original array that I am taking. And in this array, the elements are A, B, and C. I don't know like which element is there in this original array. So that's why I'm taking A, B, C. Now I have to compute like can we make elements A or B which is equals to 1 because we have given a drive array but we don't know about original array. So can make A or B equals to 1, then B or C equals to 0, then C or A equals to 1. I told you it is a cyclic kind of thing, so it will be C or A. So C or A equals to 1. Can we make these kind of things? If it is possible, then we will return true, otherwise we will return false. So for every element, we have two ways. Either it can be 1 or it can be 0. A can be 1, A can be 0. B can be 1, B can be 0, and C can be 1 or C can be 0. It means we have to do power n ways to find out the array. So it will be 2 to power 10 is to power 5, which will definitely give me the TLE because 2 power n technically won't work in if n can go up to 10 is to power 5. So what will be the better technique? Let's see. We have given derived array and this is yes. So we have given derived array and also have, we don't know about original array. So for finding out the original array, we will do the sum. Sorry, XOR. So how we'll find out the derived array? Derived array is basically A or B, which was initially 1 in this example, and B or C, which was initially 0 in this example, and C or A, which was 1. Okay. So by doing this, we can find out the original array. So what we will do, we'll take XOR of all the elements. So if we will take the XOR of all the elements, it will be like A XOR B, then XOR with B XOR C, then XOR with C XOR A. And we know the method of XOR elements, like if there are same elements, that it will be 0. Otherwise, if different elements are there, then it will be 1. So if this whole thing can give me 0, then in that way like it is a valid array. Otherwise we don't know it is valid or not, or it will be definitely unvalid array. So you want to find out a valid array. So after doing the XOR of all the elements, if it is 0, then we can say it is a valid array. So the time complexity of this whole solution will be big of n, because what we are doing is we are just doing a XOR element like XOR operation. So only one time we are traversing the array. So that's why the time complexity will be big of n and the space complexity will be big of 1. So now let's do the code for this. So what we'll do, we'll initially initialize answer as 0, and we'll just traverse the array, derived array, and we'll do the XOR of all the elements. So answer XOR equals to IT, and finally we'll return answer equals to 0. If answer equals to 0, then it is possible to make the array. It means it is a valid array. Otherwise, it is a invalid array. Like now, let's run this. This is a problem. Software and yeah, function was not there. So int answer equals to 0, then 4 auto belongs to there, and the answer XOR equals to IT. Then finally we'll return answer equals to 0. If it is possible, then it is a valid array. Yeah, it is working perfect. Now let's submit it. Now you can see it is working perfect and taking 0 milliseconds, which was good. Like, so the time complexity of this whole solution is big of L, because we are just using a loop and a single traversal, and the space complexity is big of 1, because just we are just using the variables. We are not using any external space, so the space complexity is 1. So this was the video, and if you find this helpful, then please like, share,